This video will discuss question 12. What is approximately the frequency of oscillation f0? To solve this question, we should first have a look at the open loop transfer function, and for that we need both A and beta. Beta can be found in the same way as in the previous question, by applying a ZS for the series components and a ZP for the parallel components. We can then set up beta as a simple voltage divider, as follows. If you now fill in the component values, you will finally get the following equation after some rewriting. To sustain oscillations, the open loop gain of our circuit should be equal to 1. We can write that down as follows. A times beta, j omega, should be equal to 1, and we can write that as A over 3 plus j omega RC minus 1 over omega RC is equal to 1. Since the value of A is always a real number, we know that if the open loop gain should be 1, this imaginary part should be equal to 0. So this constraint is imposed, that omega RC minus 1 over omega RC has to be equal to 0. If we then solve that equation for omega, what you will get is omega equal to 1 over RC. That is the frequency of oscillation. If you now want to get the absolute frequency, the only difference you have to make is dividing it by 2 pi. After filling in the component values, you will end up with an approximate 1 kHz.